This is for the slides, yes? Good. Over the last 100 years, the atmosphere has seen a buildup in the minor greenhouse gases from human activities. About half the increase in the greenhouse gases comes from carbon dioxide emitted by fossil fuel burning. The remainder comes from methane and other trace gases. Greenhouse gases tend to block the outward flow of heat from the Earth's surface, so a buildup in their concentration means that the average surface temperature of the Earth should warm. In fact, the global average temperature over the last 100 years has warmed about 0.5 degrees centigrade, and that is in the period in which there has been a significant buildup of the minor greenhouse gases. Now, computer simulations of the Earth's climate try to calculate the warming due to the human-made greenhouse gases. The models post-predict that a warming of 0.5 degree to 1 degree centigrade should have occurred in the last 100 years as a result of the buildup of the minor greenhouse gases. Let's see. Can somebody turn the slide projector on? I don't think this turns it on. And to go back one. Yes. And maybe focus it a little bit. Thank you. This is the observed temperature since 1880, the surface record of the Earth made by thermometers in blue, and then an averaged, time-averaged run of temperature in black. And then the predicted model from the prediction of warming from the computer simulations, showing about a 0.5 degree rise, 0.5 degree centigrade rise, predicted from the known amounts of emissions and buildup of greenhouse gases, and about a 0.5 degree rise in the average surface temperature of the Earth. So, bolstered by the apparent success of the models yielding roughly the correct magnitude of the warming, the modelers then extrapolate into the future. And here's where the trouble begins. The latest prediction calls for a best guess of about 2.5 degrees centigrade by the year 2100, given current rates of buildup and accumulation of greenhouse gases. Now, 4 predicted consequences of such a warming are: first, disruption of agricultural patterns accompanied by starvation; 2, flooding of coastal areas as glaciers and polar ice melt and the sea level rises; 3, more destructive hurricanes; 4, deaths due to the increase in tropical diseases which spread to the populated high northern latitudes. Now, these possible outcomes due to the dramatic and rapid climate change deserve some serious thought. Worldwide, the sum cost of often discussed policies for reducing greenhouse gas emissions, say reducing emissions to 20% below 1990 levels, could be $5 trillion in 1990 dollars by the year 2100. Such disruption of the fabric of the world's economy also could be disastrous and equally deserves serious thought. So what are the scientific facts in support of the claim that man-made global warming will be significant, that means larger than the natural fluctuations in the climate, and also catastrophic? First, I'll discuss the scientific basis for the global warming catastrophe. Then I'll discuss the possibility of changes in the sun's brightness as a cause of some or much of the warming and cooling observed during the last several thousand years. And finally, I will mention the effectiveness and economic impact of proposed policies for cutting greenhouse gas emissions. How do we know the computer forecasts of the climate 100 years into the future are believable? Well, we start by noting that the increase in greenhouse gases from human actions over the last 100 years, added together, are equivalent to a 50% increase in carbon dioxide alone. This 50% increase in effective carbon dioxide gives a way to test the accuracy of the climate forecasts, because we just measure the climate response to the buildup of the greenhouse gases. So we'll compare the computer predictions to the temperature record of the last 100 years. That is, we'll look at this slide in a little more detail. And we will then compare the predictions to the very precise temperatures measured by satellites over the last 17 years. And we will also make an effort to compare the warming predictions, the model predictions, to the record in the Arctic. According to the computer forecasts, the last 17 years covered by the satellites are very important, because this is the period in which the Earth's temperature should be rising very rapidly, because the buildup of greenhouse gases has been accelerating. And the Arctic is important because the forecasts say that the Arctic temperatures should rise fastest of all, and thus provide a stringent test of the greenhouse warming theory. Now, the punchline of this testing of the climate forecast reveals that the predictions fail in every major way to describe the real world. The comparison with the temperatures actually observed shows the forecasts are exaggerating the warming by a large factor. I estimate as much as a factor of 10. No evidence can be found in the scientific measurements to support the theory of catastrophic global warming caused by human activities. 3 major tests of the climate forecasts and the failure of those forecasts to explain the measurements of the climate will be reviewed in order to show why the predictions of a large temperature rise are wrong. The first test is temperature from 1880 to the present, still on this slide. This 100-year record is important because it covers the period in which the greenhouse gases have increased by an amount equal to the 50% rise in carbon dioxide. Now, the most important feature of the temperature record is that most of the warming occurred before 1940. So if you look on the chart, look at the green prediction line, it says there should have been very little warming. The observations show that most of the warming of the last 100 years occurred before 1940. So since most of the man-made greenhouse gases entered the atmosphere after 1940, that means most of the temperature rise of the last 100 years occurred before the greenhouse gases from human activities existed in the atmosphere. This violates cause and effect. And after 1940, the buildup of greenhouse gases in the atmosphere accelerated, but the temperature dropped. One thing the greenhouse gases cannot do is cause cooling as they increase. So the buildup of greenhouse gases cannot be the cause of the half-degree warming that occurred between 1880 and 1940. The computer forecasts are exaggerating the warming that should have already occurred due to the 50% buildup of greenhouse gases. Second test, temperature records from the Arctic. And according to the computer forecasts, the polar areas are very sensitive to global warming. The forecasts say the polar regions should have warmed by as much as 5 degrees centigrade during the last 50 to 100 years, enough to begin melting polar ice. Melting the polar ice produces a positive feedback that amplifies any warming. The reason is that ice reflects sunlight and helps keep the polar regions cold. But as the temperature rises and the ice melts, the bare ground or sea underneath absorbs more of the sun's energy and then magnifies the warming. What about reality? Recent Russian and American temperature readings in the Arctic were combined and analyzed, and they yield a very good record of temperature in the Arctic over the last 40 years. On the average, the temperature has not risen at all. So in the test of the Arctic, the computer forecasts exaggerate the warming by a very large amount. It should have risen as much as 5 degrees, and in fact, there's been wintertime cooling in the Arctic. Temperatures measured from satellites are also an important test. Yes. In the last 17 years, very precise readings of the temperature over the entire Earth have become available from satellites, which are making measurements truly globally as opposed to the surface measurements, which are mostly over land. The computers predict that the buildup of greenhouse gases is now so large that the global temperature should be rising at a rate of 0.2 to 0.3 degrees centigrade per decade. And I've drawn in that prediction in red here on the slide from the start of the satellite record. But the satellite readings show the temperature has not changed at all in the last 17 years in response to the buildup of greenhouse gases. Now, the Arctic should have warmed by about 1 to 1.5 degrees centigrade, according to the predictions in the last 17 years. There's the predicted temperature rise. And again, the satellite readings prove that computer forecasts are exaggerating. Not only has there been no warming, the Arctic's been cooling. Now, the satellite record is often criticized on the grounds that it does not truly represent surface temperature, because the satellite readings relate to altitudes of at least 4 kilometers. But the satellite record agrees perfectly with the ground-based thermometer readings when the surface readings are spatially dense. In other words, the disagreement between the satellite and ground readings is where the ground readings are sparse and are filled in by extrapolation. Over much of the southern oceans, for example, extrapolations may cover 1,000 kilometers or more. Moreover, many of the climate simulations have sufficient vertical resolution to make temperature predictions at different altitudes. Many of the simulations say that the warming should be most aggressive near 4 kilometers, exactly the altitude sampled by the satellites. And as stated earlier and shown in these charts, the satellite readings at that altitude show no warming. You may have read about aerosols. In the last year, much attention has focused on the impact of man-made aerosols such as sulfates. In fact, the soundbite conclusion from the latest Intergovernmental Panel on Climate Change policymakers' summary is that, quote, the balance of evidence suggests a discernible human influence on global climate. The reason for the conclusion is that the computer simulations now add in the cooling effect of aerosols, which lower some of the temperature projections and bring them closer to reality. Aerosol pollution shades the surface from the sun and keeps the land cooler. So increased cooling by the aerosol pollution just might counterbalance increased warming due to the buildup of greenhouse gases and mask the warming. But there are several problems with this argument. First, the effect of aerosols was handled in the computer simulations purely on the basis of modeling. That is, no hard data were ever used to test any of these simulations. Second, the computer simulations are claimed to be valid based on good regional success in predicting the greenhouse plus aerosol impacts in different areas. But the regions are precisely where the computer models fail. For example, simulations in North America and Eurasia, where the temperature records and a lot of the aerosol records are quite good, show a worse fit for aerosols added to the greenhouse gases than for the greenhouse gases alone. So adding the aerosols in made the fits diverge. Third, aerosol pollution in the US has declined sharply since the 1970s because of the series of Clean Air Acts. An ever-decreasing amount of pollution cannot mask an ever-increasing amount of greenhouse warming, so aerosol pollution cannot explain the observed lack of a large greenhouse warming across the continental United States, whose temperature is not warmed in about 100 years. Fourth, reality in the Arctic again brings great trouble to these climate simulations. Even with modest aerosol burden in the models, and we know that the Arctic has in fact very little aerosol pollution, one of the favorite of the aerosol models says that the Arctic should have warmed by an incredible 10 to 12 degrees centigrade. As mentioned earlier, and still on this slide, the Arctic has not warmed. So the computer forecasts are exaggerating the greenhouse warming by a very large factor. The temperature rise of the last 100 years comes before the time of the major increase in human-made greenhouse gases. And the great warming predicted for the last 17 years does not show up in the very precise satellite measurements. So what is the maximum amount of warming due to increased greenhouse gases that can be expected to occur if we correct these exaggerated forecasts to the limits allowed by the actual temperature measurements? The answer is that the corrected warming in the next century, at present rates of increase in greenhouse gases, will be less than about 0.2 of a degree centigrade. Spread over a century, that will not be significant compared to the natural variability. Now, Professor Richard Lindsay at MIT has stressed that the models are subject to major errors because we still do not understand the very profound impact of water vapor both in the air and in clouds. It is impossible for the computer predictions to treat correctly the action of water vapor and clouds on climate change because the physics is not understood. Now, over 90% of the greenhouse effect is due to water in these two forms. As a result, the computer predictions lack the ability to describe the large part of reality. In a review article in Nature in 1992, Dr. Shaheen, who is presently the chief scientist at NASA JPL, concluded that, quote, the errors in calculating the basic greenhouse effect remain too large by about an order of magnitude to let us determine the impact of the increased carbon dioxide on global warming. Now, as new results in physics come in, the models have changed. And the IPCC predictions have been cooling significantly in the last few years. This chart shows the history of the predicted warming for the year 2100 and the year the predictions were made, starting in 1989. Now, the straight line fit to the predictions says that near noon on March 22, 2001, a warming of 0 degrees centigrade will be predicted. Against this background of scientific ignorance, the puzzle is why the computer forecasts are used in serious policy considerations. Now, most of the warming early in this century must have been due to natural causes of climate change. These natural causes, including changes in the brightness of the sun, must be understood in order to make an accurate determination of the effect of any man-made climate influences. These natural changes are not well understood. In the case of the sun, we lack an adequate theory of the sun's changes and their potential climate impact. Thus, we must try to infer the sun's climate forcing from terrestrial records and work back to build a theory of the sun climate influence. The surface of the sun is covered by sunspots, and the area or number of these sunspots, which are sites of very strong magnetic fields, waxes and wanes roughly every 11 years. But the period of this sunspot cycle is not exactly 11 years. It compresses and stretches from 8 to 15 years. Other periods of the sun's magnetism are also present. For example, an 80 to 90 year period called the Gleisberg cycle, a 200-year and possibly a 2200-year period. There may be longer periods, and we really lack information on the sun to be able to determine whether or not there are longer periods. The 200-year period of solar magnetism is quite interesting. Every 2 centuries or so, the sun's magnetism drops to very low levels for several decades. The most pronounced period in the historical record of sunspots, which was begun in 1610 with Galileo, this pronounced low period of solar magnetism occurred between 1640 and 1720 and is called the Maunder minimum. At that time, sunspots were rarely seen on the surface of the sun. Now, the Maunder minimum is a known recurring feature of the sun's magnetic changes over the last 7,000 years, which is about the length of record that we have for solar magnetism. Now, how can one build up a record of solar magnetism going back 7,000 years if the direct record of sunspots only begins in 1610? The reason we have this record is that the sun's magnetic activity is recorded in records of cosmogenic isotopes, such as radiocarbon, carbon-14 that is, and beryllium-10. Both isotopes can be formed in the Earth's atmosphere as a byproduct of energetic cosmic rays, which originate in deep space and sometimes hit the Earth's upper atmosphere. The sun's magnetic field, carried to the Earth by a solar wind, deflects some of these cosmic rays. So at times when the sun's magnetic field is strong, more cosmic rays are deflected, and the formation of carbon-14 and beryllium-10 isotopes in the upper atmosphere is inhibited. Conversely, with weak magnetic field from the sun, on the sun, more cosmic rays hit the atmosphere and the abundances of carbon-14 and beryllium-10 rise. Some of these isotopes are then incorporated in geologic records. For example, some of the tagged carbon dioxide in the atmosphere is taken up by trees and stored in their cellulose. Beryllium-10 is carried by precipitation into ice layers near the polar regions. The small amounts of these isotopes measured in the lab from tree ring and ice core samples yield a history of solar magnetism going back several millennia. The isotope records confirm the occurrence of this very low magnetic minimum, Maunder's minimum, in the 17th century, and it also says that it occurs every few centuries, going back some 7,000 years, and that there are also occasional episodes of grand magnetic maxima. Now, while it is obvious that the magnetism of the sun changes dramatically on timescales from days to thousands of years, it is unclear how magnetic changes per se could affect the climate of the Earth. In the 1980s, satellites recorded the sun brightening and dimming in step with the sun's 11-year magnetic cycle. Near the height of the sunspot cycle, the sun is bright. At sunspot minimum, the sun is faint. Now, it may seem counterintuitive that at times of maximum coverage by dark spots, the sun is bright. But careful study of the surface of the sun shows that the dark spots are accompanied by surrounding bright areas of strong magnetism called plage. The plages cover more area than the dark spots do. So the increased light from the bright plages more than make up for the light blocked by the dark sunspots. Hence, the sunspot cycle of magnetism is really a curve of varying brightness of the sun. In other words, the sun is a variable star with a period of 11 years or so. These brightness changes associated with the magnetic changes may provide a mechanism for helping change the climate of the Earth. Now, recent discoveries do implicate solar brightness changes as a cause of climate change over the last few centuries. This chart shows a record. This chart shows a record of changes of the surface temperature of the northern hemisphere land, and that's in blue. And maybe can somebody focus it? It looks blurry to me. And then superposed on that in red is a change in the length of the 11-year cycle, the sunspot cycle. Now this correlation, although I've only showed it from its original discovery paper in 1991 by 2 Danish astronomers, this correlation holds as far back as there are reliable records of sunspots and climates over 240 years. In addition, many climate records, meteorological records, show very sun-like 11-year and 22-year periods. Now, brightness changes on the sun are an obvious mechanism for causing terrestrial climate change, but the records only go back 18 years, the length we have been monitoring the sun by satellite. And that interval is too small to really study changes in climate over, say, 100 years or 1,000 years. But records of solar magnetic variability go back 7,000 years. And we know from the satellite data that the brightness changes and the magnetic changes on the sun are highly correlated. And we also have other observations of sun-like stars, which help us make these correlations as well. Putting this all together yields an indirect record of the sun's brightness over a very long interval of time. So how do the great swings in solar magnetism and presumably the sun's brightness compare to climate change? Proxy records of climate change going back 5,000 years show that 6 out of 7 coolings on the Earth of 1 to 2 degrees centigrade correspond to these long-term lulls in the solar magnetism, these Maunder minima. Our most recent estimate is that the sun changes in brightness by about 0.5% between the states of very low and high magnetism. And that is enough to explain the timing and magnitude of the observed climate changes going back 5,000 years. Simulations of the Earth's climate over the last 100 years, in the interval when the man-made greenhouse gases have been put in the atmosphere, indicate that changes of several tenths of 1% sustained over several decades and timed to the changes in the solar cycle explain up to 96% of the variance in the temperature record. That is essentially all the variance. And you can see that so when you look at a curve like this, there is no room for the warming by man-made greenhouse gases. This curve of the solar variability completely explains the temperature record. That's why the fit is so good. Now, over the last 1,000 years or so, to go into a little more detail on some of the climate changes, the climate has tended to follow the changes in the solar magnetism. Europe has a proxy climate record going back that far and is an interesting case study in the consequences of some of the climate change that's occurred. First, to set the stage, Europe experienced its warmest temperatures of the last 2,000 years in the 10th to 12th centuries, when the sun was at one of these sustained high levels of magnetism, one of these grand magnetic maxima, and even higher than the levels today, which are high but not higher than in the 10th to the 12th century. This period was also called the medieval climate optimum, and vineyards flourished in Britain. But by the 13th century, the magnetism of the sun was declining, and so was the temperature over Europe. The prolonged winters and cold temperatures beginning in the 13th century lasted until about the last of the 1800s, the late 1800s. This interval is called the Little Ice Age, although it's not climatologically like a major glaciation of the Earth. The average global temperature was only about 1 degree centigrade cooler than today, although in northern Europe, for example, the North Sea region was some 5 degrees centigrade cooler. The harshest intervals were coincident with the lulls in the sun's magnetism, that is in the 13th, 15th, 17th, and 19th centuries. The cooling caused a dramatic increase in the severity and frequency of storms and a great increase in sea flooding. Now note that increased havoc is closely linked in the last 1,000 years of climate history to times of cooler rather than warmer temperatures, which suggests that the man-made global warming would mean less storm destruction. Now, this sudden deterioration in climate in the late Middle Ages following the decline in solar magnetism was devastating for pre-industrial Europe. For example, in 1315, grain failed to ripen due to early winters. The frequent shortened growing seasons of the 14th century produced severe famine and deaths from starvation and disease. Cannibalism was reported even in Western Europe. The life expectancy decreased by 10 years from about 48 years to 38 years. One of the most horrible diseases of the 14th century was ergotism, or St. Anthony's fire, and was clearly the result of the poor climate. Ergot blight poisoned the kernels of rye during damp harvests at the time. Ergot, in the smallest amounts, baked in bread, would cause an epidemic of convulsions, hallucinations, gangrene, and then sure death. In 1332, the worst weather disaster in history occurred when severe rains caused great flooding in the central river valleys of China. Over 7 million people died, and the ecosystem was destroyed. Rats carrying the fleas that harbor bubonic plague scurried tried to find livable areas, and possibly migrated to Western Europe by hitchhiking with crusaders and traders traveling from Europe to the east. Thus did the great bubonic plague arrive in Europe from China in 1348 to 1350, and it recurred during intervals of poor climate, which were timed with low solar magnetism, and the poor climates were the times when the resistance of the population was lowered. Up to 2/3 of the people in some areas of Europe died, and probably 1/3 of the population of Europe was killed as a result of these Black Death epidemics. As for storms, over 100,000 people died in floodings of the North Sea in great storms in 1421 and 1446, and a storm in 1570 resulted in the deaths of over 400,000 people. The number of very severe floods on the North Sea coast in the last 2,000 years seems to have been greatest in the early 1400s and late 1600s. There were about 3 times more disastrous floods at that time than in the 20th century. The moral of this is that history says that times of global cooling, not warming, are disastrous, contrary to what one reads in the newspaper. Now, the temptation to adopt a policy of do something about global warming is always sold as needed insurance against the possible risk of a catastrophic warming, despite the scientific facts that say otherwise. That portrayal of insurance as a prudent hedge is wrong on 2 counts, notwithstanding the scientific lack of detection of the fingerprint of warming. First, the notion of insurance is a carefully calculated premium paid against a risk known reasonably well in outcome and probability of outcome. In the case of man-made global warming, the risk, the premium, and the outcomes are not well defined at all. More important is the second element of the flawed insurance analogy, the notion that buying a reasonable policy of doing something will actually have an impact on the buildup of man-made greenhouse gases in the atmosphere. The problem is that the concentration of greenhouse gases in the atmosphere will continue to build unless emissions are drastically cut. For example, a voluntary approach to reduce emissions to 1990 levels in the U.S. by the year 2000 is the heart of the administration's U.S. Climate Action Report, which was released October 6, 1994. Unfortunately, the plan only mitigates the predicted temperature rise by about 10%, or 0.2 degrees centigrade of a predicted 2 degrees centigrade warming, assuming that all countries, including China, obey the notion of emission limits. That is because the buildup of greenhouse gases continues at current or slightly reduced rates of emissions. The emissions have to be cut substantially in order to halt the buildup already in place. Now, the Climate Change Action Plan was submitted to the UN by the US in response to the Rio Treaty. This treaty is specific in addressing the buildup of anthropogenic greenhouse gases. Article 2 states, quote, "The ultimate objective of this convention is to achieve stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system." In order to stabilize the concentration of greenhouse gases at current levels, emissions of carbon dioxide or the equivalent in some greenhouse gases must be cut by nearly 80%. Now, what would a cut of 80% in effective carbon dioxide emissions or some greenhouse gas emissions entail? I've developed a pedagogical example to consider an 80% cut taken up entirely by carbon dioxide, since the effect of the greenhouse warming, as we said earlier, can be always stated equivalent to carbon dioxide. Now, in the US, we could achieve these cuts by forbidding the generation of that amount of electricity made by coal, which for generating our electricity is the worst one in generating carbon dioxide. So we forbid the generation of that amount of electricity that would remove 80% of the total inventory of US carbon dioxide emissions. Now, 55% of the electricity in the US is supplied by coal. And to make the 80% cut, we would have to forego the electricity supplied, half the electricity supplied by coal. And that would make our 80% reduction in the carbon dioxide emissions. Now, if the generation of electricity by coal could be rapidly and inexpensively replaced by another means which does not emit greenhouse gases, then the problem is solved, well, at least theoretically. However, the choices at the moment are quite limited. Neither nuclear power nor hydroelectric power emit greenhouse gases. But it is inconceivable that the institutionalized impediments will be quickly removed so that those alternatives will be further developed. Now, natural gas produces a bit of greenhouse gas emissions, so if it is used as a substitute, natural gas would have to replace more of the electricity generated by coal. However, I estimated to make that 80% cut in carbon dioxide emission, it would drive the price of natural gas in the short market up by about a factor of 5. And it's not clear that we have enough natural gas supply to do that in any case. Now, sharp carbon dioxide reductions have also been proposed through demand-side management and also sequestration of carbon. My favorite example of sequestering carbon is to grow a lot of fast-growing trees, clear-cut the forest, take them to the deep ocean and dump them. You're sequestering carbon, or build furniture or books or something out of them. What you're doing is you're putting carbon in the trees and then taking them out of the atmosphere, taking that carbon out of the atmosphere. So some proposals have been made to massively afforest the US, not reforest, but afforest substantially more. These notions of demand-side management or massive afforestation cannot possibly make up for the 80% cuts in emission. These are just wishful thinking. So that leaves us with the only way to achieve the treaty's goal is to do without this portion of the electricity. That is, half the electricity generated by coal. So what would it cost to forego, and we have to do this rapidly in order to stabilize the concentrations of greenhouse gases in the atmosphere, what would it cost to rapidly forego the emission of half the electricity generated by coal, which is about 27% of the electricity in the US? Now, a rough estimate is that that corresponds to a cost of 1/4 of the GNP of the US, not 0.25%. 25% of the GNP of the US annually. The reason is that electricity drives GNP, and the relation between GNP and electricity generation has been approximately linear in recent years. So if you can't replace the electricity and you have to do away with 1/4 of it, you cut the GNP by 1/4. So these reasonable insurance policies that have been proposed to cut emissions are not large enough to stabilize or reduce the concentrations of carbon dioxide and the other greenhouse gases that the treaty calls for. Reducing the concentrations of the greenhouse gases in the atmosphere by making these 80% cuts will lead to world economic trauma. Limits only on the emissions, such have been proposed, are lulling us with siren songs that we are doing something about global warming, when in fact we're merely squandering public resources on our emotions and in defiance of scientific and economic facts. Now, what if we're wrong? What if, despite the best interpretation of the temperature records, what if the major global warming still is occurring, but for some reason its fingerprint has not been observed? Then we can estimate the penalty paid of the increase in temperature in the next century by delaying these reductions in greenhouse gas emissions, and that penalty is quite small. For example, assume that global warming will cause a temperature rise of 2 or 2.5 degrees centigrade by the year 2100, which, as we know from looking at the science, that number is exaggerated. In that case, in the case of the 2 to 2.5 degrees centigrade warming, the exaggerated warming, the extra temperature rise that would occur if we delay by 10 years action on these policies to limit emissions is less than 0.2 of a degree centigrade. That penalty of an extra tenth of a degree spread out over a century will be entirely negligible against the backdrop of natural climate change, and is therefore a penalty that we should be more than willing to pay. That seems a very small price while waiting to obtain better information on the science of climate change. Thank you. I wanted to finish early to answer questions, if there were any.
Last year, it was Freon that you defended as a pseudo-villain rather than coal this year. How many deaths, that is depopulating, which is the problem that many of these, depopulation is what many of the environmentalists wish, because humans are the problem for them. How many deaths do you think would result from the lack of refrigeration, from not having electricity?
Maybe Fred Singer can help me answer that question. I know in developing countries it's a great problem. Making electricity more costly in this country is probably not going to result in greatly many deaths, but in developing countries it would. I don't know if Fred has any comment. Fred Singer.
Have you testified before the United States Congress, or has your data and your interpretation been admitted to the IPCC panel or any of the other authorities that might make a difference?
I have testified in front of the Senate and Congress. I have been asked to review the IPCC documents, but it's not clear to me that our standards of peer review are mutually agreeable. And so I haven't bothered to respond to their calls for reviewing.
How are you received by the Congress or by the committee?
I don't know. I guess you'd have to ask them. And I'd be glad to send you the testimony. It's very factual. Maybe I should also mention that whenever there are polls taken of this global warming issue, the science behind it, of, say, the American Meteorological Association, most of the scientists say that there is no evidence for catastrophic warming. And that is, in fact, what the past IPCC reports have said up until the one this year, whose policymaker summary was carefully crafted. And Fred Singer, I'm told, will speak about that this afternoon. Yes?
I suppose all of us have heard the commentaries in the news media, evening news and so forth, about what scientists are saying about global warming. Is it possible that the scientists that they are referring to are political scientists instead of physical scientists?
Well, I can give you two pieces of guidance on that. One is Stephen Schneider, who was often quoted on the global warming issue and who had a book about the catastrophe of the coming ice age in the 70s and then the catastrophe of global warming in the 80s, and is now a biology professor at Stanford, said that it was okay to make up scary scenarios to get public attention, and that each scientist has to decide the line between being effective and being right. And in my mind, that line doesn't exist for scientists. There is only being right. The other thing I would suggest you do, and I'll be glad to make copies of this, is to look at the underlying science document of the IPCC, not the policymaker summary. And the quotes in here are quite revealing. I've taken some snippets out. no method exists of providing confident predictions of future climate. The only horizon of proven reliability for providing weather forecasts is a few days, or at most a few weeks into the future. And the document, the science document itself, has many of the caveats in it that all the climate scientists expect to be in there. That there is no attribution of man-made warming that can be made. It's what gets published in the media is what promoted in the media and what's in the policymaker summary that's caused some mischief and misperception. And I don't know the reason for that.
I think your presentation is excellent and
thank you.
Do a lot of good, a lot of places. There's just a couple points that might even emphasize to the public, like most of us are to read the newspaper. One is that carbon dioxide sounds like it's a sin to have it around and whatnot. But if you want to pay attention to one thing, carbon dioxide emissions, carbon dioxide in the atmosphere is the beginning of the food chain for the whole planet.
Is absolutely right. Without carbon dioxide, we would die. Not because, not because we breathe it, but because plants, which are essential, use it.
Well, that's one point. See,
yes.
What you're going to have at lunch today was one time emitted from a coal-burning furnace or an automobile or whatever it is. That's where CO2 ends up. All the carbon that's in carbon dioxide goes into plant growth, but it sounds better if you say food preparation for the whole plant.
Yes, yes, the food chain. I did not get to talk about the paleoclimate, which is very interesting because it reveals that we're in, geologically speaking, a relatively starved era for carbon dioxide. Back through past history, the carbon dioxide levels have been much higher, and in fact, there's an interesting time in the Ordovician, some 440 million years ago, where the carbon dioxide levels were some 14 times higher than they are today. 14, not just a factor of 2, 14. And you might ask, well, the models would then predict some catastrophic global warming. Well, it was a major ice age, major glaciation over most of the Earth.
Just one other item that we see in the newspaper too is the fact that this 1 or 2 degrees centigrade increase comes about. We're going to have 15 to 25 centimeters rise in the sea level. Well, in this famous paper, Access to Energy, about 3 or 4 years ago, sort of pointed up something which I'll just emphasize now, that most of the melting of the ice, at least in the north in the Arctic area, is because of the flow of surface, the Gulf current in the Atlantic and the Japanese current in the Pacific circulating around, and that's where it tends to melt the ice. When it melts a cubic foot of ice, the space melted by a cubic foot of ice has to be filled by 1.2, something like that, cubic feet of water. So until the cap gets, till the atmosphere temperature gets down where it starts melting continental ice, why melting of the ice in the Arctic or the Antarctic by seawater is going to lower the sea level rather than raise it.
Yes, I have 2 quotes I'll give you from the IPCC. There is no evidence for any acceleration of sea level rise this century. And this was written before, last Thursday I got a press release from NASA saying their satellite observations of sea level rise that they started making several years ago and hit the newspapers as saying that there was some evidence for sea level rise, turned out to be a little problem in their computer code that overestimated the sea level rise, and that's been reduced by about a factor of 4 to namely insignificant levels. And of course, on the notion of the floating ice shelves, changes in floating ice shelves, of course, says the IPCC, cannot affect the sea level directly, as anybody who floats an ice cube in a glass and watches it melt knows. Yes?
You touched on one of the points that I wanted to make. In the past, the Earth has had a number of periods of global warming and global cooling, resulting in glaciation, both major and minor. And if you ask the climatologists what caused all these, they have no idea. They have a number of theories. If they don't know this, then how can they attribute present global warming over a single century to anything?
It's the heart of the matter.
Sallie, in your pedagogic example of how we would go about decreasing CO2 emissions by 80%, You use natural gas as an example instead of nuclear energy. The reason I bring it up is twofold. One is that nuclear should be less prone to the cost of energy being pushed up in the same way that natural gas as demand went up. And second, nuclear energy is a dilemma for the extreme environmentalists.
Yes.
Of course, because on the one hand, they don't like nuclear energy production. On the other hand, it's the obvious solution for their maunderings about global warming.
It's exactly right. What I said about nuclear was that these institutional impediments, as I called them, will not go away quickly. And natural gas people seem to be willing to use. I think there's not enough natural gas to supply that, especially on a short time scale. But you're right.
The previous questioner gave part of what I wanted to present, that the very same proponents in the House and the Senate of this global warming scenario are fighting with a vehemence to kill the integral fast reactor, which burns as its fuel the waste of the light water reactors. The alternative is stored for 30,000 years.
Mm-hmm. Mm-hmm.
And it is inherently safe, passively safe. It cannot blow up like Chernobyl or 3 Mile Island. I happen to have pamphlets on the integral fast reactor.
I'd love
And
that.
tomorrow I can have more. I have
Great.
This thick of documents and papers that can be copied for anybody that's interested. And there is only 6 months left to save this prototype reactor. A year ago, the Senate said, take it apart, dismantle it,
Right.
but you can't turn a reactor off.
No.
It takes 18 months to unload the fuel. There's only 6 months left.
No.
And here it is safe, inexhaustible, clean energy,
Yes.
which is the solution as the previous
Yes.
15 to be percent.
I have no wisdom in this matter. As a mere scientist, I have to quote Sir Isaac Newton, who says, I can calculate the motion of celestial bodies, but not the madness of men.
Just a moment. The whole global warming and ecology movement is kind of anti-technology. You know, man is unnatural and so on and so forth, and so many different aspects to it. But in fact, CO2 emissions could be characterized, it just occurred to me, once before the characterization of it as sort of global recycling, because, and maybe that's what we should, someone might be interesting to someone with a name on the issue to write an article, because all we're doing, man's job on Earth is to, make up when nature's, to pinch it when nature's kind of move things up a little, and take all these fossil fuels, which were organic matter, and put them back into the atmosphere where they can be recycled instead of buried underground, and turn into plant life again. And all automobile combustion and all electricity production is nothing more than man helping nature recycle. And to stop it is to be opposed to global recycling.
Another blow against the madness of men.
Dr. Fred Seitz has said in effect, and I questioned him about this at the DDP conference in Tucson 2 years ago, that the amount of carbon dioxide already existing in the atmosphere is probably sufficient to absorb all of the radiation, or about all of the radiation that can be absorbed in the spectrum it is capable of absorbing, so that the addition of more CO2 probably will have little or no effect on global temperatures. Do you support what he says?
I do, because the physics of water vapor is at issue here. Carbon dioxide is a minor greenhouse gas. It is at best part of the natural warming, a few percent. So doubling it, just even if the opacity lines were not opaque, really just doesn't seem to make any difference. It's really water vapor is driving everything, and since we don't understand water vapor, that's why the models are getting warming.
Sallie, before I ask my question, I've been impressed by the questions, and I'd like to suggest that people, when they ask questions, introduce themselves so we know who all these brilliant people are, well-informed people. I'll introduce myself. I'm Reed Urban. I have accuracy in media. You referred to NASA revising or correcting the error in its recent release. Was this the same release in which they came out saying that had improved data and were able to measure the satellite measurements of the temperature? I don't remember all the details of it.
No, this
I'm sure you do.
Yeah, this came out last week, and I'll get you a copy of the release. It was on the Topex Poseidon experiment, and it's not about temperature. It's really about that measures only the surface layers of the Earth, the surface layers of the ocean, and tries to look at their height.
Would you care to comment on that release that came out? I think it was within the last week about the revisions and the measurements.
Yes, a year or so ago, there was a newspaper story that said that in the previous 2 or 3 years since the satellite had been launched, there had been seen a dramatic rise in sea level. And over that 2 or 3 years, that dramatic rise in sea level was then interpreted to mean that that was a signature of global warming. When one looked at this in detail, one found that the dramatic rise in sea level was due merely to a natural event called the El Nino, a warming of the southern oceans, and that the ocean expanded in response to this El Nino. And you also cannot tell anything about a long-term warming by looking only over 2 or 3 years. So I felt on its face that that press release last year was quite foolish. This release said that the large warming the large rise they had seen had not occurred to that degree. It was reduced by a factor of several. So it is in fact doubly insignificant.
As you know, and everybody in the room knows, Howard McAbee. I'm a physician, radiation oncologist. I'm also previously a biophysicist. Everybody in the room knows that if you warm up a soda, the gases in the soda are driven out by the increase in temperature, such as carbon dioxide or water vapor. And by the same token, if you warm up ocean water, you will get increased CO2 coming out of solution and probably water vapor, as well as we know from evaporation. So there's a notion opposite to the standard global warming hypothesis that CO2 drives warming, and that is that warming drives CO2 and H2O into the atmosphere. And I have looked at the long-term trends in a very crude way, and it does seem that the temperature increases seem to come just before the increases in CO2 that have been measured from ice and things like that. You have obviously done a lot more paleoclimatology. What do you think of that notion that warming drives CO2 and H2O rather than vice versa? And how much of these effects are accountable by that as compared to the effects of the sun temperature and sunspots, et cetera?
The changes, what one can measure from deep drillings of ice cores brought up from Greenland and the Antarctic, where the sediments, the precipitation, the snow falls every year and doesn't melt, and then measure the isotope content in these ice cores and the carbon dioxide content, and get a measure of both the temperature and the carbon dioxide content of the atmosphere going back some 150,000 years. This is the best record I know of to test this idea of which comes first, the warming or the carbon dioxide. And on that time scale, and from those data, I've looked at it pretty carefully. What happens is you can see the carbon dioxide and the temperature going up and down together, and this is through major glaciations, which happen on those time scales of tens of thousands of years. The carbon dioxide change comes first in those data, and the temperature change is second. I'm sorry, it's the other way around. The carbon dioxide change is second in response to the temperature change. So something causes the temperature change, and in response, carbon dioxide is either absorbed or emitted from the ocean in response to that change in temperature. So in that case, carbon dioxide does not cause the temperature changes. They are the consequence of it, and it's quite clear. What causes those major swings in temperature, the major swings in and out of the glaciations, is still under dispute, but it's thought to be changes in the dynamics of the Earth's atmosphere brought about by changes in tilt of the Earth in its orbit around the sun. And the reason is that the ice ages seem to occur on very, very geometrically periodic intervals of 10,000, 20,000, 40,000, 100,000 years, which are related to, which are the timescales of phenomena of changing of the Earth's orbit, the change in the eccentricity of the Earth's orbit, the drift in the axis of the rotation axis of the Earth. Now, those changes in the Earth's tilt are quite small, but it's thought that changes in the distribution of sunlight on the surface can drive these major circulation changes and cause the glacial, the times, or at least trigger in the episodes into and out of these ice ages.
I'm David Horn. I'm a chemical engineer. Work here in Salt Lake City, Hill Air Force Base, actually. My primary work is with fuels. Do a lot of work with energy conversion. In our area here, we have a lot of our water. Most of the water in the Salt Lake area, for example, comes from underground wells. Water that falls in the mountains and trickles down through the rock, picks up carbonates. And as it comes down and is released at lower elevations, these carbonates in large, or I shouldn't say large measure, to some extent, evaporate into the atmosphere. You go out in some parts of the state, in Nevada, and there are large areas where the land is barren because we have hydroxide-rich soil caused by the carbonates evaporating into the atmosphere. So there's a possibility that some of this carbon dioxide, and maybe even a large quantity of it, goes into the atmosphere, is actually being brought down and is being produced from the rock through which the water trickles after it falls as rain and snow. However, I had a question about what the proponents of the global warming theory propose about what we can do about it in reducing the amount of fuel that we use, both coal and hydrocarbon fuels, liquid hydrocarbon fuels, and gaseous fuels like propane and methane. Have you heard of any proposals about mandatory increasing insulation in homes, or improvements in our engines that we use for transportation? As an engineer, I'm aware of techniques that have been developed to increase our engine efficiency so that a car, 8-cylinder cars, specifically research that's been done here in Utah, cars with 8-cylinder engines are getting in excess of 100 miles to the gallon, but government regulations are preventing this being implemented.
In terms of climate change regulations, the Climate Change Action Plan is voluntary. The administration's response to what the Rio Treaty asks us to do is a voluntary reduction of emissions to 1990 levels by the year 2000. Now, it turns out it's getting very late in the decade, and emissions have gone up in the last decade, so our ability to reduce those is getting more difficult. But these are voluntary, so there's no mandatory actions required by the Climate Change Action Plan. However, the treaty does call for reductions in concentrations. So sooner or later, the treaty will have to meet, the regulations will have to meet the treaty unless we decide our treaty obligations are not valid. But at the moment, everything is voluntary. Thanks.